It's like opening a brand new package.
This wing is actually meant for a future project I'm working on. I'd like to share with you guys how this high lift airfoil wing is cut. But before we continue, make sure you click that subscribe button if you haven't and hit that notification bell. This wing is being cut on a 4-axis CNC 3D printed machine that I built a while ago. If you haven't seen that video, make sure to check it out. I'll leave the link somewhere on the screen or the video description. The airfoil I choose for this project is the S1210. It's a high lift airfoil made specifically for low speed RC aircraft. It has a lot of camber, which means it can generate lift at very low head speeds. Before generating the G code, the first thing I did was to download the SVG file from the airfoil plotter website. I added the parameters I needed before plotting the airfoil profile. Then I downloaded the SVG file into my computer. After downloading, I uploaded the SVG file to a website that converts it to DXF. After converting the file, I downloaded the DXF file and imported it to Fusion 360. After the file is imported, what I needed to do now is to trace out the offset I already added of about negative 2 millimeter. What this will do is to add a thickness to the trailing edge of the airfoil. It's very important that the splines are only 2 splines, as this very next step is important. The DXF to that converter can be downloaded on RC Kit's website. Make sure to check it out. I will leave a link in the video description. You'll find loads of useful information about CNC there. Once the DXF file is exported, I took it to the DXF to DAT file converter. With this software, you'll be able to convert the exported DXF into DAT, and the DAT file is what we're going to be using to generate the G code for this airfoil shape. I took the DAT file that I generated to the website called DIYRC Wings. I'll be leaving a link in the description. What this website does is that it allows us to generate a G code from the DAT file that we've uploaded. Within the software, you can add aileron cutouts, spar holes, and it also allows you to change the chord length of your airfoil profile and many other features that is available on this software. So make sure to check it out. Once I configured all my foam cutout parameters, I simulated the G code, make sure everything is okay before exporting it. Before proceeding to cut the actual foam, I made sure to carry out a small test cut just to check out the settings.
All right, here's the test cut for the actual airfoil that I'm going to be cutting later on a bigger scale. And the reason why I did this test was because to make sure if anything is going to go wrong, let it go wrong on a smaller scale. And then it will allow me to also make some modifications so as to avoid any kind of errors. This airfoil is the S1210. It's a very high camber airfoil, and as you can see, the cut came out pretty neatly. I'm pretty happy with these results. And what I've done here is to add 2 spar holes, which I'll be using some carbon fiber rods to reinforce the actual wing. Like I said, it's very important to have a test cut because when you're cutting with a CNC cutter, you need to make sure you have your temperature and your speed at the optimum best for your foam density. Because if you are changing your foam density, you will need to also change your speed cut and your temperature for your hot wire. So that's what this test is for actually. I'm pretty happy with these results. It's a very nice clean airfoil cut. So now that is said, let us cut the actual wings.
Cutting this wing took a bit of a time, and that is because I have set the feed rate to be slow. If you're interested in this CNC machine, make sure to check out the link in the video description.
Time to see what the results are. The first wing has been cut, and this is just one of 3. I still have to cut 2 more, which I'll be joining together later. If you can see these 2. Yep. So let's check it out. It's like opening a brand new package. Nice. Nice. This is beautiful. Don't you just love this? This is wonderful. Okay. All right. So as for the trailing edge, definitely we need some trims later. But yeah, I'm pretty happy with it. It had a couple of thickness at the tip. Same thing here as well. Very nice, beautiful cuts. Okay, most importantly now, let us check the carbon fuses, carbon spar. All right, so I'm happy with the results. Just need some trims, and I have three more to print. I said print. I have three more to cut. All right, so now I have all the wings cut, and I had to split the last wing because already the fuselage width is already adding to the wingspan of the wing. So I had to reduce the actual size. It was just like this before, so I had to split it as well. So one side will be glued to the other side of the wings. And if you notice, this wing does not have a spar hole. That's because it's going to be located at the tip. So because of that, there's no reason to put a spar all the way to the wing tip. Let me just show you real quick. So it's going to be glued together like this, as you can see. Yep, just like that. Once it's glued together, all the necessary trims will be done, and I would have my wing. So I don't know, right wing, left wing, it doesn't matter now because it's a straight wing. So once we get to that stage, you'll figure it out. But I'm pretty happy with the clean cuts.
This CNC is a 4-axis CNC and it can actually cut tapered wing too as well. So make sure to check it out. If you made it this far and you haven't subscribed, please subscribe and I'll see you in the next video.